Hey everyone, welcome to this new PowerShell 7 module for my PowerShell Masterclass. If you've not seen the Masterclass before, it's a free playlist on my YouTube channel. If you go to playlists, you'll see PowerShell Masterclass, and then there's a number of different lessons about all the different aspects of PowerShell. Kind of lesson one's got nearly 100,000 views. So this is really just designed to help introduce you to PowerShell. With this new module, with PowerShell 7 now released, I thought it would be a good idea to actually go through exactly what is PowerShell 7, how do we get it, and then a look at some of the new features. So firstly, how did we even get here? Now, in the first lesson of the masterclass for PowerShell, I kind of covered the history of PowerShell. So that's Windows PowerShell, the different features that were added as it progressed, even PowerShell Core. But for Windows PowerShell, it was built on the .NET framework. So .NET framework exposes pretty much every aspect of the Windows operating system. And so PowerShell, built on that .NET framework, could really hook into every aspect of the Windows operating system. But we don't live in a pure Windows world. And so .NET Core was introduced. Now this had a subset of the functionality, the APIs of the .NET framework, but it was now supported cross-platform. We could use it on Linux, on Mac OS. And so PowerShell Core was introduced. It was built on .NET Core 2.0, and instead of being PowerShell.exe, it was PWSH.exe. That let it coexist. It meant I could explicitly specify which version I wanted to run. However, because it was built on .NET Core, and .NET Core didn't have all the same APIs as .NET Framework, not all modules would work on Core. For example, if it hooked into WPF, things like Out-Grid View did not work. But this new PowerShell Core was cross-platform. It was open source. So you'll actually see contributions from the community. And you could go and look at a PS version table. That would give you details about the version, the edition, and if you were running Core or the desktop version. So here I'm in Windows Terminal. It's a great interface to use for PowerShell and other command line interfaces. I have a Windows PowerShell tab open. You can see I can also do other tabs I can add. I can select which one I want. Command, PowerShell, Windows PowerShell, even the Azure Cloud Shell. But if I look at my PS version table, well, we can see I'm running 5.1 and it's the desktop version. If I do the same thing in my PowerShell 7, if I do my PS version table, you'll see I'm 7, I'm running Core. I also have a git commit ID. That's really going to be the main versioning we care about. I can see the OS, I can see the platform. And there's some nice little variables. For example, I can say, well, is this Windows? Yes, it is. Is it Linux? No, it's not. Is it Mac OS? No, it's not. So I can easily kind of check. If I look at the modules that are available on the system, it will actually show me if it's compatible with Core and or desktop, or just desktop. So you can see there's ones that are desktop only, but we get that information. As an interesting aside, if you ever use the Cloud Shell in the Azure portal, if you look at the version table here, you'll actually notice it's running on Linux. This is a Linux container that powers the Cloud Shell. So here, if I check for is it Linux, it's going to be true. When I think about the evolution and how we got to where we are, so obviously we had the .NET framework and then .NET Core. So Windows PowerShell was built on the .NET framework. PowerShell Core built on .NET Core. The last version of Windows PowerShell is 5.1. So that's delivered now in the operating system. I think with Windows Server 2019, maybe the anniversary or 1809 of Windows 10. WMF provided this to other operating systems. That is the last version of Windows PowerShell. There is no more investment in Windows PowerShell. There is no more investment in the integrated scripting environment, the ISE. but it's still provided in box. It's rock solid. It's got a huge amount of functionality. If you've got automations using it, fantastic. But the investment is all in PowerShell core. So we had version 6. So this was built on .NET Core 2.0. This moved to things like PowerShell configuration files instead of using the Windows registry. So it would actually work for things like Linux and Mac OS. No, there were still user profiles, that's separate. But we had this brand new PowerShell core. Then we had 6.1. That was a shift .NET Core 2.1. That improved a lot of compatibility. And then we had 6.2, which was mainly about performance and bug releases. Notice that was called PowerShell Core. Now we have just PowerShell. With this, we now have PowerShell 7. This is built on .NET Core 3.1. The next version of PowerShell 7.1 will be built on .NET Core 5. So I say .NET Core 5, that's actually wrong. It's going to be called .NET 5. So for .NET, they've really reached a point that their core foundation has really reached a parity with the .NET framework, and that's the direction going forward. So there was a .NET Framework 4.8. No more work is going to be done there. It's moving to .NET 5. .NET Core becomes .NET 5. So to PowerShell Core now becomes PowerShell 7. So it is still built on .NET Core, but with the huge advancements they've made in .NET Core 3.1, huge amounts of things like WPF compatibility. So now PowerShell 7 is about 85% compatible with Windows PowerShell 5.1. And it has a whole bunch of other compatibility capabilities I'll talk about. So even modules that don't work on PowerShell 7 natively will still fairly transparently just be available. But to show you some of this stuff, so if I was to just think about this compatibility, if I jump over to a session, let's say I quickly start a process for Notepad. So there it is. I can now do things like, well, let's get process. And now I can do an out to grid view. I could do a pass through and then stop process. So if I run that, it's now popping up that window. I could now select. So this is now possible because of this .NET Core made a ton of investments in 3.1 about all those new APIs. So I can now render this graphical element. I can select it and Notepad went away. I can do other cool stuff now from a compatibility perspective. So once I've got Notepad, I can do things like, well, let's set the clipboard with a value of hello from PowerShell. Now if I go into Notepad and just paste, there it is. I could say hi from Notepad, copy that, and I could do git clipboard. So now I have this greater compatibility because of all that investment in .NET Core 3.1. That's going to continue with .NET 5. PowerShell 7's taken advantage of that, and it's just going to get really better and better. Now, the exact installation varies. I can go to aka.ms/get-PowerShell for a link to all of the different installations for Windows, Linux, Mac OS, ARM, Docker, etc. Also on the GitHub page, PowerShell, it has links to all the different versions. Now on Windows, I can install PowerShell 7 side by side with Windows PowerShell. In fact, I kind of need Windows PowerShell for that compatibility for the incompatible modules. If I have PowerShell Core 6 installed, that will get replaced by PowerShell 7 during the installation. Now, if I have the .NET Core SDK installed, I can actually install PowerShell 7 as a global .NET tool. And what the global means is that it's still installed in my user area, but that installation path is added to my user path and it will be available everywhere for me. It's not available to other users, it's just there for me. This is really designed around developer type installations rather than a mass user deployment. But I can absolutely install that. That would be super useful if I'm using DevOps. I want to quickly build and test. I can make PowerShell available via that. I can easily upgrade it. There are MSIs that I can install via SCCM. There are MSIX. I think we're going to see this in the Windows Store. There are zip files. I think this is going to grow. It's going to be available in more and more places. I think integration with WSUS. No old versions will be removed. If you love MSI, fantastic. It's going to be there. There are also a whole bunch of Docker images published with PowerShell 7 built in. Now, what about upgrading it? Now, by default, today, a check is performed periodically for a new version. I think it's the first session in any 24-hour period, it will go and check. If there is a new version, it will say, hey, look, there's this new version, you should go get it. It doesn't currently automatically upgrade. It doesn't provide a clickable link because today Windows Terminal doesn't support hyperlink VT escape sequences, nor do some Linux terminals, but this might change. I think we are going to see this evolve. It wouldn't surprise me to see, for example, the Microsoft Store having this, having WSUS catalogs having this. If I'm using the .NET Global tool, then I can easily update it using the .NET Tool update command. If I'm using Linux, I can do things like apt-get update. But we're going to see more and more evolution here. Also, some of the tools like PowerShell Get. PowerShell Get 3 will be released pretty soon. That's going to remove its reliance on the package management module. It will hook straight into NuGet provider. So that's going to experience more changes as well. So how do we use it? Now, for command sessions for interaction, Microsoft Terminal is great. Now, I don't have to use that. If I just jump over to an environment, if I just go to my Start menu, if I just type PowerShell, you'll see I've got PowerShell 7. I can launch that. There's the easy little run as administrator. And from this environment, there's lots of configurations I can do about the font, about buffers. I can make it kind of transparent if I want to. So there's a lot of flexibility here. But a huge amount of the direction is going into this Windows Terminal application, because I can easily have multiple types of shell available to me. It has a really rich environment. So definitely recommend go to the store, the Windows Store, and you can download the Windows Terminal. In terms of script editing, I can't use ISE, the integrated scripting environment. It doesn't work with PowerShell Core or PowerShell 7. VS Code is replacing that, and it's much better. VS Code actually has PowerShell specific extensions to provide a great editing experience. And it also has integration with Git. So if I'm using source control, it can actually go and do a lot of that work for me. I can even configure the default terminal in VS Code to be PowerShell 7. So if I was to jump over, if I go and look at my VS Code, this looks pretty familiar. This looks like the ISE. I can even bring up PowerShell commands. And the way this is working, if I look at my extensions, I have the PowerShell extension installed. I have things like user snippets. And once I have that extension installed, if I open the command palette, so I can do view command palette, if you just type ISE, you can see enable ISE mode. It's going to make it look like the ISE. It gives me things like these little run buttons. Hey, look, I can run selection. People like the buttons, apparently. This gives me a nice environment to work in. I can do break, I can do debug. This is really where you want to go. And as you can see, I've got integration with source control. So I'm going to hide that for a second. So definitely think of VS Code as that place that I want to do my scripting, debugging for PowerShell. If I go to my command palette, I can actually go to settings, and here we'll actually see I can open user settings. This gives me this kind of graphical interface, but also I can open my user settings through JSON. This is where I could go and configure really anything I want about this environment, because it's got the color theme set to PowerShell ISE, editor tab completion is on, etc. And just like PowerShell Core, I have remoting, yes, via WinRM, but also SSH, so I have that kind of cross-platform capability. So now let's think about, well, what can we do with PowerShell 7? So firstly, the module compatibility. The Windows compatibility module is no longer required. So in PowerShell Core, this gave us the ability to create this implicit local session into Windows PowerShell, where we could then load modules which would be projected into our PowerShell Core session so we could use them, but they actually run in the Windows PowerShell session. Because of the .NET Core 3.1 foundation, as I talked about earlier, more things now just work in PowerShell 7. But there's also this built-in compatibility layer that's really behaving in a very similar fashion as Windows compatibility module. Now, this is used automatically for modules in System32. So PowerShell 7 knows about all of the modules in System32. It knows if they will work for PowerShell 7, i.e. Core natively, or if they need the compatibility. So if it needs compatibility, they are automatically loaded using the compatibility layer. If I'm loading a module that it can't tell, maybe it's not been flagged as its compatibility, I can use -use Windows PowerShell. So that's a new switch for import module that will force it to load using the compatibility layer. If I don't want to use the Windows compatibility capability, then I have this disable implicit WinCompat setting that can be used to block that compatibility use. So let's look at if I have any PowerShell sessions. So I don't have any. And what I'm going to do is I'm going to import the Azure AD module. And I'm saying use Windows PowerShell. Now the Azure AD module is desktop only. So now if I look at my PS sessions, you'll see I have a WinPS compatible session to my local machine. If I actually look at my task manager, what you would actually see as well is it would have spun up a PowerShell instance. So if I go and look, then there's PowerShell. So it's actually created that for use with this session. If I look at my modules, well, now you can see I've got Azure AD, but notice it's of type script. So what this compatibility layer does is essentially create a script for all of the commands in that module, and now exposes it to me. For example, if I actually go and get one of the commands like Azure AD, so that's going to be connect Azure AD, I can look at that command. Notice it's a function. If I look at that, well, what it's really done is it's created this wrapper, and essentially it's going to invoke the native command, passing it all the parameters to that implicit remoting session, and it's just going to pass my connect Azure AD. So that just happens for me automatically. I don't need to do anything for that. It's now just that native compatibility layer that's built into PowerShell 7. And of course, there's new stuff. First one, for each object now has a parallel switch. So ordinarily, for example, let's say I pass an array of 10 objects, could be event logs, whatever that is, database connections. It would run the code that I specify within that for each object parameter, but they would run in series. It would run the first one, then the second one, then the third one, etc. Then in the past, people might use workflows to run these in parallel. Well, now I have this parallel switch, which based on the number of throttling I set, will run a certain number just in parallel. The default is 5. So let's look at an example. Here I'm just creating an array of 10 numbers, 1 to 10. Very, very simple. So I'm going to take this line and execute it. And then what I'm going to do is just run for each object, sleep for 1 second. So we would expect this to essentially take 10 seconds because it's getting past number 1, then 2, then 3, and it's just going to sleep for a second for each one. So we see this takes 10.01 seconds. Well, now I'm going to run it passing -parallel. I'm going to set the throttle limit to 10. Now, you can mess around with this. You could set this super, super high. It's really designed to be tens, not thousands, but you can mess around. So if I run this, it's finished. So it finished in just over a second. Now, the reason it finished in just over a second is it's basically creating a run space for each of these parallel threads. Setting up that run space takes an amount of time. So if I had operations that were super fast, this may not help me. But if I'm doing operations that take tens of seconds, then this is really going to speed things up by running them in parallel. So now super simple, easy to run those parallel actions. There are now ternary operators that give me this simplified if-else. This is common in other types of language. Well, now I can just do a condition, question mark, and then what to do if it's true, colon, what to do if it's false. So for example, I'm going to set a path that it won't find, and then I'm testing the path, question mark, path exists, colon, path not found. And as we expect, it says path not found. If I set it to a path that is there, well, now it's going to say path exists. So again, just really simplifies my code. I don't have to use this. I can still do the regular if, else, etc. It's just a way to do it pretty quickly, maybe simplify my piece of code. We now have these new pipeline chain operators. It's based on the $question mark, which is going to return true or false if it was successful or it failed. And I can think of this as kind of and, or, i.e. the pipe. And what this is going to say is the and is like, well, run what's on the right hand of the pipeline if the left hand succeeds. With the or, pipe, it's going to execute the right hand pipeline if the left hand fails. So we jump over again. I can say write output hello and write output world. I would expect write output hello to work. And so we see hello world. If I do write error, it's going to kind of set that $question mark to false. Well, now I just get hello. It doesn't execute the write output world because the command on the left did not succeed. If I do or, when I do that write error hello, well, now it says hello world because essentially we got a failure on the left because we wrote an error. It's now going to run the code on the right. If I just do write output and it succeeds, well, then it doesn't execute write output on the right. So that's the idea. Once again, I can kind of simplify now bits of logic to say, hey, if something succeeds, then do this. And if something fails, do this. Once again, simplifying my code. We have null coalescing operators to handle a variety of different null situations. So I can think about my answer is null. So I'm just setting it to null. So I can say, well, my answer, question mark, 42. So what this says is, if what's on the left is null, return what's on the right, i.e. 42. So it returns 42. If my answer is not null, then it's going to return the answer, i.e. PowerShell. And I can perform actions as well. I could say, for example, well, get a module. Let's say Azure AD. And then if that's null, i.e. it couldn't find it, it will go ahead and install the module Azure AD. It doesn't need to do anything because that is installed on this box. Likewise, I can set values. So if I set the answer to null again, I can say, well, $answer, question mark, equals 42. So if it is null, well then we'll set it to 42. So I'll run that. Now my answer is 42. If my answer was already PowerShell, and I run the same command, it stays as PowerShell. Now there's also some new things about operating members of a variable, accessing entities of a variable. Now this is an experimental feature, so I had to enable PS null conditional operators. If I look at experimental features, you can see here, actually they're all false. So let's go ahead and enable experimental features. Notice I have to restart, so I'm going to close this down. And then what we will do, we'll find VS Code again, and we'll reopen it. And now if I get my experimental features and run this command, now we can see null conditional operators is set to true. So what we can do with this is, notice here we have this question mark, and we have to put the process, the variable name, in the squiggly brackets. We might call them curly braces in America, because variables can have a question mark in it, so I have to be explicit. So I'm going to start Notepad. So there's Notepad. I'm going to get the process, and then look at the process ID, so that works. If I stop Notepad, so Notepad's gone, and run that same command again, so that's going to be null. When I run this, it won't even try to access .id. It knows this is null, so it checked it with the question mark, so it won't even try to access. Likewise, if I have multiple elements, so here I've got an array of 10 numbers, I want to look at the first item, array 0, so it's number 1. If it was set to null, once again, it won't even try to access. It knows numbers is null, so by using the question mark, it won't even try to access. So that's using these various new types of null coalescing capabilities. There was a lot of feedback in showing error messages, making them easier to read. So let's just make sure I've set my variable for my local path, or I'm going to get a different error. So now if I try and get a child item on a folder that's not there, cannot find path C not there because it does not exist. If I run a script, notice it's helping me. It's saying, hey, look, the script has an error. At line 2, it's showing me the command that had the error, and then exactly what the error is. It's using color to try and really bring it to my attention. So there's this improved error view. And finally, there is some experimental DSC resource capability. It's not the full scope of DSC. I don't have access to a local configuration manager, but at least I can start applying DSC now to resources. So I hope this was useful. This was just really going through what's there in PowerShell 7. I hope you like this video. Please give it a like if you do. Subscribe, share. Love to see your comments. And good luck in all your PowerShell endeavors.